Imagine standing in a dark field on a clear night and looking up. You see the band of the Milky Way stretching across the sky. It looks peaceful, doesn't it? Just a static river of light.
It does look peaceful, but we know that reality is chaos. It's gravity, fluid dynamics, and massive explosions happening on a loop for billions of years.
Exactly. And for astrophysicists, understanding how our galaxy evolved from a cloud of gas into the spiral structure we see today is the ultimate puzzle. To solve it, they build simulations.
But here is the catch, and it is a big one. Until very recently, no computer on Earth could actually simulate the Milky Way accurately.
What do you mean? We've had supercomputers for decades. Surely we can model a galaxy.
We could model the shape of a galaxy, sure, but not the individual stars. The Milky Way has over 100 billion stars. Previous simulations hit a wall. They could only handle a mass limit of about 1 billion suns.
So they were missing 99% of the stars?
Not exactly missing, but they had to cheat a little. To make the math work, scientists had to group stars together. The smallest particle in those old models wasn't a single star. It was a cluster representing about 100 suns.
I see. So it's like looking at a digital photo, but the pixels are way too big. You see the general image, but you lose all the fine details.
That is the perfect analogy. Because they were averaging things out, they couldn't accurately simulate individual events, specifically things like supernovae. And that's a problem, because when a star explodes, it changes everything around it instantly.
And I assume calculating those explosions takes a lot of computing power.
An immense amount. Here is the staggering statistic. If you use the best conventional physical simulation we had without any new tricks and try to simulate the Milky Way down to the individual star, it would take 315 hours just to simulate 1 million years of history.
315 hours for 1 million years, but the galaxy is billions of years old.
Right. If you wanted to simulate 1 billion years of galactic evolution at that rate, you would have to run the supercomputer for 36 years in real time.
Okay, nobody has time for that. You'd be retired before the simulation finished. So, I'm guessing the research we're discussing today found a way around that.
They did. And it's a massive breakthrough. A team led by Keiya Hirashima at RIKEN in Japan, working with the University of Tokyo and others, just pulled off the world's first simulation of the Milky Way with 100 billion individual stars.
100 billion? So they aren't grouping them anymore.
Individual star resolution. And they did it using a hybrid approach. They combined traditional supercomputing with artificial intelligence.
Okay, break that down for me. How does AI help simulate gravity and gas?
Well, they identified the bottleneck. The thing slowing everything down was calculating those supernovae explosions and how the gas expands afterward. It requires tiny time steps and complex math.
So instead of doing the math,
they used a deep learning surrogate model. Basically, they trained an AI on high-resolution simulations of supernovae. The AI learned exactly how gas expands for 100,000 years after an explosion.
I think I get it. So when the simulation reaches a point where a star explodes, instead of crunching the heavy physics equations for days,
the AI steps in and says, I know this pattern. Here is the result. It predicts the outcome instantly without using resources from the rest of the model. It's like a massive shortcut that doesn't sacrifice accuracy.
That's incredibly smart. It's bypassing the grunt work. So what does this do to that 36-year wait time we talked about earlier?
This is the best part. Remember, the old way took 315 hours for 1 million years of data. This new AI-driven method, it took 2.78 hours.
Wow. From hundreds of hours down to less than 3.
Exactly. That means if they want to simulate 1 billion years of history, it won't take 36 years anymore. They can do it in about 115 days.
That turns a lifetime project into a semester project, and they verified this?
Yes, they ran large-scale tests on the Fugaku supercomputer and the Mayabi system to prove it works. It represents 100 times more stars than state-of-the-art models, and it runs 100 times faster.
I think this feels like one of those moments where the tool itself changes the science. If we can simulate the Milky Way star by star, we can finally test theories about where we came from.
Precisely. Hirashima, the lead researcher, pointed out that this is not just about recognizing patterns, it's about tracing the elements that formed life. We can see how materials from supernova explosions travel through the galaxy to eventually form planets like Earth.
And I imagine this tech isn't just for space, right?
No, and that's the wider implication here. This surrogate model approach, using AI to handle the small, complex parts of a big simulation, could revolutionize weather forecasting, climate change models, and even oceanography.
Because those fields also have multi-scale problems. You have to model tiny raindrops and massive hurricanes at the same time.
Exactly. It's a fundamental shift in high-performance computing. We are moving from pure calculation to a mix of calculation and intelligent prediction.
I think it's fascinating to think that by teaching computers to imagine the explosion of a star, we can finally see the whole galaxy in high definition.
It really is. We are getting a front row seat to the history of the universe, accelerated by AI.
Thanks for diving in with me. This is a huge step forward for science.
Anytime, it's always great to look at the big picture.